Hello, in this video, we're focusing on the practical concepts that you can actually apply in the real business world. Hope you enjoy it. Let's get on with it. Hello, in this video, we're focusing on the practical concepts that you can actually apply in the real business world. Hope you enjoy it. Let's get on with it. Today, we'll explore why Microsoft is investing billions in nuclear energy to power their future AI data centers. As AI technology evolves and demands more computing power, it also requires a reliable and sustainable energy source. Nuclear energy offers a consistent, low-carbon power supply that can meet these needs better than many alternatives. This investment reflects Microsoft's commitment to innovation and sustainability, ensuring their AI centers can operate efficiently while minimizing environmental impact. We'll look at how this strategic move fits into the broader goals of technological advancement and clean energy development. Artificial intelligence is facing a major challenge, not because it's running out of ideas, but because it's running out of electricity. Every impressive AI system, from chatbots and real-time translators to autonomous machines and large-scale model training, needs a huge, constant supply of power. Unlike typical cloud services that can scale their energy use up or down, AI systems operate relentlessly, requiring energy levels comparable to those of entire cities. This immense and continuous power demand is the real bottleneck for AI growth. The biggest limitation right now isn't the software, the hardware, or even the experts behind AI development. It's the availability of reliable and sufficient power to keep everything running smoothly. This is why addressing energy supply is critical for the future of AI. Microsoft's decision to invest billions in nuclear energy marks a significant change in how they view energy, not just as a cost, but as a critical factor that can limit or enable growth. By restarting old nuclear reactors and funding new ones, Microsoft aims to avoid the unpredictability of the power grid. This approach lets them control their energy supply more directly, creating a strong advantage as computing demands grow, especially for AI. In an era where scaling AI depends heavily on reliable and plentiful energy, those who manage power best will lead. And Microsoft is clearly positioning itself to do just that. Artificial intelligence changes how data centers use energy in a big way. Unlike traditional cloud setups that see ups and downs throughout the day, AI runs constantly. It needs a huge amount of power packed into small spaces and can't handle any interruptions or voltage drops. Instead of growing its power needs slowly, AI ramps up in big jumps. Just one large AI data center can use between 300 and 500 megawatts all the time, which is like powering hundreds of thousands of homes. When you think about many data centers like this across different regions, it's clear that the current power grid is under serious pressure to keep up. Most national power grids weren't built to handle the rapid increase in energy demand driven by AI technology. They face long delays in creating new connections, traffic jams on transmission lines, and slow regulatory processes that complicate upgrades. There's also a lack of reliable on-demand power sources that can be dispatched when needed. Even in places with lots of renewable energy, the power supply is inconsistent without huge investments in storage systems. This means that getting grid access has become the main bottleneck for expanding AI capabilities, rather than the computing resources themselves. For a company like Microsoft, which runs one of the largest cloud and AI platforms globally, relying on the grid to catch up simply isn't a practical option going forward. Nuclear energy offers a unique solution because it provides firm, reliable power at scale, something wind or solar can't match due to their variability. Nuclear plants run above 90% capacity, meaning they deliver consistent electricity day and night, regardless of weather. This steady supply is essential for AI infrastructure, where any downtime isn't just inconvenient, it poses a serious threat to operations. This stable, continuous power ensures the AI centers can function smoothly without risking interruptions, making nuclear energy a clear fit for meeting the high, always-on energy demands of advanced AI systems. Microsoft has set clear goals to reduce carbon emissions and prioritize sustainability. While fossil fuels like gas and coal could quickly supply the needed power, Relying on them would increase emissions and likely trigger regulatory challenges, not to mention harm the company's long-term reputation. Nuclear energy stands out because it produces no operational carbon emissions, delivers enormous and reliable power, and the plants can operate for decades. This unique combination enables Microsoft to meet the huge energy demands of AI technologies while staying true to its environmental commitments, even as those commitments face growing pressure from rising energy needs. One of the biggest advantages nuclear energy offers is that it's not starting from scratch. Over the past 2 decades, many reactors in the US and Europe were shut down, but it wasn't because they were unsafe. Instead, it was largely due to low power prices, cheaper gas and renewables, and policies that favored other energy sources. Microsoft saw a key opportunity here. Restarting these existing sites is much faster than building new plants. These locations already have permits, grid connections, cooling systems, and skilled workers in place. This means that nuclear energy can move from being a long-term hope to a practical near-term solution to meet the increasing energy demands driven by AI and other technologies. Microsoft's involvement with 3 Mile Island Unit 1 highlights a key part of its strategy to solve energy challenges for AI and cloud services. This reactor was shut down in 2019 due to economic reasons, but under a 20-year power purchase agreement, it is now being recommissioned to provide over 800 megawatts of carbon-free baseload power. A significant share of this power will support Microsoft's AI and cloud data centers directly. By underwriting the economics of the plant, Microsoft avoids typical grid limitations, especially transmission bottlenecks, by anchoring power generation right at the source. This deal is more than just about megawatts. It marks a shift where large tech companies act as active sponsors of energy infrastructure, helping create and shape supply rather than just buying power when it's available. This approach aligns well with the need for reliable, clean, and scalable energy for AI workloads, solving both environmental and operational challenges in an innovative way. Microsoft's approach to nuclear energy combines both near-term and medium-term strategies. In the short term, restarting nuclear plants that were shut down for economic reasons offers a quick way to secure reliable, large-scale power. This leverages existing infrastructure, reducing development risks, and helps fill the gap between current grid limits and future energy needs. Looking ahead, Microsoft is also investing in small modular reactors, which are factory-built and can be placed nearer to data centers. These smaller reactors have faster permitting processes, standardized designs, and lower upfront costs, allowing energy generation to be closely aligned with where data processing happens. Together, these strategies create a layered portfolio that balances speed, scale, and innovation to support Microsoft's energy goals. Microsoft is creating a strong feedback loop by applying AI directly to nuclear technology. They're using AI to make nuclear licensing faster and smoother, enhancing the design and simulation of reactors, optimizing plant operations and maintenance, and cutting through the heavy paperwork and regulatory hurdles. This isn't just about using nuclear energy to power AI. The process actually helps nuclear technology advance more quickly and efficiently. In essence, AI and nuclear energy are working together to accelerate progress on both fronts. This approach goes beyond energy. It's a comprehensive system strategy that leverages technology to build better infrastructure for the future. Nuclear investment offers clear, practical benefits for businesses like Microsoft. One key advantage is the ability to scale power needs on your own schedule without waiting years for grid interconnection approvals. This avoids delays caused by crowded utility queues and lets Microsoft control when and how it grows. Another important benefit is cost stability. Energy prices can be unpredictable, creating risks for operating budgets and financial planning. Nuclear power agreements provide long-term price certainty, which helps improve forecasting and the return on data center investments. Over the long run, spanning 20 to 40 years, relying on nuclear energy can actually be more cost-effective than dealing with fluctuating spot market prices or depending heavily on renewables combined with energy storage. This mix of predictability and independence makes nuclear a smart, reliable choice for business energy needs. Enterprise customers prioritize reliability. including strong uptime guarantees and geographic redundancy to ensure their AI services never go offline. Environmental, social, and governance credibility is also a key factor, with energy security becoming a visible part of Microsoft's product value, not just an internal matter. By owning the energy supply, Microsoft gains strategic flexibility, allowing data centers to be placed where it's most efficient, increasing the utilization of costly AI hardware, and enabling faster deployment of new models and services. This shifts energy from being a limitation to a strategic advantage, giving Microsoft a significant edge in delivering consistent, scalable AI solutions. Microsoft's nuclear strategy brings several clear advantages across different areas. Strategically, it allows Microsoft to operate independently of unstable power grids, giving full control over the growth pace of AI infrastructure. The investments also create long-lasting infrastructure assets that support ongoing innovation. From a financial perspective, nuclear energy helps lower energy costs over the life cycle of data centers, minimizes downtime risks, and improves returns on capital invested in those centers. Environmentally, it provides large-scale carbon-free baseload power, reduces dependence on fossil fuels, and aligns with national goals for decarbonization. For Microsoft, adopting nuclear isn't about ideology. It's about making smart, practical economic decisions that support business growth and sustainability. This strategy demands significant upfront investment, with billions of dollars tied up in capital costs and long payback periods, making it a commitment that lasts for decades. There's also the risk of regulatory changes which can impact the project's viability over time. On top of the financial challenges, nuclear projects often face political and community opposition due to concerns about safety and water usage, especially around expanding infrastructure like data centers. Successfully managing these issues requires careful and sophisticated engagement with stakeholders to address their concerns and maintain support throughout the project. Restarting reactors and deploying small modular reactors come with specific challenges. There can be delays in licensing and bottlenecks within the supply chain, not to mention shortages in skilled labor. These delays can be especially problematic because the demand for AI won't pause for us, it moves quickly and requires consistent energy availability. On the financial side, as AI grows faster than anticipated, Microsoft must carefully manage the balance between honoring its climate commitments, deploying capital wisely, and ensuring smooth operations. These pressures on the balance sheet make it essential to navigate this strategy with precision to support both our sustainability goals and the operational needs of AI expansion. The bigger picture here is that AI competition isn't just about software or talent anymore. It's evolving into a battle over infrastructure. While models and algorithms can be replicated and skilled people often move between companies, having reliable and controlled access to power isn't something you can easily copy or acquire quickly. By owning part of its energy supply through nuclear investment, Microsoft is building a competitive edge that strengthens over time. This strategy is similar to how major companies in the past secured their dominance by controlling critical infrastructure. Think of how railroads own their tracks, telecoms own fiber networks, or oil companies controlled pipelines. In each of those cases, owning the infrastructure became a key factor that shaped who won in the long run. Microsoft's move reflects this same principle, making energy not just a utility, but a crucial strategic asset that supports sustainable growth and differentiation in the AI space. Microsoft's commitment to nuclear energy goes far beyond a simple experiment in sustainability. It recognizes that in the age of AI, the availability of electricity is a core factor for success. By bringing old reactors back online, investing in emerging nuclear technologies, and using AI to manage energy operations, Microsoft is shifting energy from just another cost to a key strategic resource. This approach changes how infrastructure is scaled today, especially as AI has made it clear that cloud services rely on tangible physical assets. Nuclear power emerges as a critical advantage in this landscape, offering a reliable long-term foundation that supports the rapid energy-intensive growth AI demands. In essence, Energy isn't just a utility anymore, it's a competitive edge that shapes the future of technology. If you found this video useful, there's plenty of more business and finance videos on the channel that you'll enjoy watching and get great practical value from. In the meantime, thanks for watching.